I want to talk about the 4 basic properties of the logarithm. So I have 4 statements here. For logarithms base b, and remember b, our base, has to be bigger than 0 and not equal to 1. And that actually comes from our ideas of exponential functions. So I want to evaluate these 4 statements, and they become my basic properties of the logarithm. The log base b of b is saying, hey, what power do I raise b to in order to get b back? Well, that's what first powers do, right? Because 3 to the first is in fact 3, which would tell me the log base 3 of 3 is 1. So if you had the log base pi of pi, you'd have 1. The log base 1.1 of 1.1 is, well, 1. Log base b of 1 asks me what power do I raise b to in order to get 1 back? Well, that's what raising something to the 0 power does, as long as b itself isn't 0. And we've already ruled that out by saying b has to be larger than 0. This next statement is actually just almost silly. What power do I raise b to get b raised to the x power? Well, that would have to be x. So while seemingly silly, if I think about the function f of x is b raised to the x power, we define the logarithm to be its inverse function. So these two functions are inverses. So if I compose them, this function here actually being f inverse of f of x, for these to be inverses of each other, I have to get out x. So this is actually an inverse function property. Using the idea of logarithm, to get b to the x, I have to raise b to the x, so that makes sense, but it's also this nice property of inverse functions. This next one happens to be f composed with f inverse of x, which also has to be x because they're inverses of each other. So b raised to the log base b of x also has to be x. And so we can actually use this property of inverse functions to figure out that that is x as well. Or we could rewrite this statement as a logarithm. The exponent, the log base b of x, is equal to, well, the log base b of x. And of course that has to be true, so this side always had to be equal to x, so that I could write that down like that. So I want to do 4 examples where we use these 4 properties. So I'm asked to evaluate the following, and I always take that to mean exactly. We're not going to use a calculator. So here I have the log base 5 of, well, let's see, 25 is 5 squared. Cube root is a 1/3 power. So this is really the log base 5 of 5 to the 2/3. Well, the log base 5 of 5 raised to the x power has to be that power, so we just get out 2/3. Here I have the natural log of e. Well, I need to remember that the natural log is a logarithm base e, and so that should be 1. I raise e to the first power to get e back. And here I have one of those inverse function properties, 7 raised to the log base 7 of 2, that has to be equal to 2. And finally, the log base pi of 1, what power do I raise pi to get 1? That has to be 0. There are our basic properties of the logarithm.